Hello, Calculus 1. This is Professor Ken. I just got back from Paris and I'm hanging out with my dogs over here. This guy, my German Shepherd is Eddie, and the golden whose head got cut off a little bit, her name is Bella. Anyway, here I am. And I wanted to make a quick little video about how we could use the definition of the derivative to find a formula for the slope of a tangent line, which is also called derivative at any point. And that's called the functional derivative. Last video, we learned how to find the derivative at a point. Now we're going to learn the formula for the derivative at any point, which is called the functional derivative. So I'm going to share my screen. And I'm going to turn off the video so my good looks don't distract you. All right, so let's go to the whiteboard. And here we are at the whiteboard again. All right. I'm going to choose my pen. Okay, so suppose we have a curve. And we have a point X and a point C. And here's the point X, f of X. And here's the point C, f of C. And suppose maybe it's some sort of a parabola. Okay. What if we wanted to find the slope of the tangent line, which is also called the derivative, at the point X, f of X? Well, if we have this other point C, we can draw the secant line. And of course, we could use the slope formula to find the slope of the secant line. So the slope formula would be f of X minus f of C all over X minus C. But if we were going to find the slope of the tangent line at X, and really X could be any point, we would want X and C to be so close to each other that they're on top of each other. So in other words, the limit as the X value approaches C. So that would mean when X and C are equal to each other. And of course, if you plug in a C for X, you get 0 in the denominator. So it's not just a matter of plugging and chugging. All right. So let's see how this would work with a polynomial function. Let's start with f of X equals 3x squared minus 2x. And this is actually easier than finding it at the point. And then, so what would be the value of f of C? F of C would equal 3c squared minus 2c. So using the definition for the functional derivative, it's the limit as x approaches C of, and again, this is just a version of the slope formula, f of X, oopsies, is 3x squared. I'm plugging into this formula, 3x squared minus 2x minus f of C is right here, 3c squared minus 2c all over x minus c. Okay, let's do some distributing. So we would have 3x squared minus 2x minus 3c squared plus 2c. And it'll be the limit as x approaches C. I'm sorry, over x minus C. Okay. Now, watch this. It's the limit as x approaches C. Let's group the 3x squared minus 3c squared. So it'll be 3x squared minus 3c squared. And then minus 2x minus 2c, because it's a plus 2c, so two negatives, positive, over x minus c. Okay, you can see we got some factoring to do. So it's the limit as x approaches c. Pull a 3 out of there. 3 times x squared minus c squared. Minus, pull a 2 out of here, x minus c. Over x minus c. Now we can't just cancel these x minus c's here because they are not being multiplied by the whole thing. You can only cancel factors. Factors are terms that are multiplied by everything. But if you look at this x squared minus c squared, we can factor that. So we have the limit as x approaches c of 3 times x plus c times x minus c minus 2 times x minus c all over x minus c. And something crucial happens here. So we have an x minus c here, an x minus c here. We can factor it out. When we do that, we get the limit as x approaches c. This is good stuff. Of x minus c. Woo! Crap. I gotta find my eraser. Well, there it is. X minus c times 3 times x plus c minus 2. And we could clean that up later if we need to. Over x minus c. And these x minus c's will cancel out, thankfully. All right, so now we take the limit as x approaches c. So wherever we see it c, we can replace it with an x. X plus x is 2x. 3 times 2x is 6x minus 2. So what does this mean? It means that we can graph this function, and regardless of what x value we choose on that graph to draw our tangent line, the slope of the tangent line is going to be 6x minus 2 for whatever value we choose x to be. So if we wanted to find out where x equals 4, we'd put a 4 in there. Where x equals 19, you put a 19 there, and so forth. Good times. All right, so now we're going to try another function. Now we're going to let f of x equal a radical 3x plus 1. And then f of c would equal a radical 3c plus 1 plus 1. So it's the limit as x approaches c of f of x minus f of c over x minus c. And we know that's the salt formula. So let's do some plugging and chugging. The limit as x approaches c. F of x is radical 3x plus 1 minus a radical 3c plus 1 all over x minus c. Now, when in doubt, multiply by the conjugate. Okay, let's do it. So we get radical 3x plus 1 plus radical 3c plus 1. Same thing in the denominator. Radical 3x plus 1 plus radical 3c plus 1. All right, so in the numerator, we get this term squared minus this term squared. When you square a square root, it just cancels out. So we have the limit as x approaches c of 3x plus 1 minus 3c plus 1 over x minus c times radical 3x plus 1 plus radical 3c plus 1. Okay, rocking and rolling. All right, look at the numerator. Let's regroup it so we can start to do some factoring. We'll call that 3x minus 3c plus 1 minus 1. 1 minus 1s will cancel, won't they? Oh, I forgot to do my denominator. Times x minus c over radical 3x plus 1 plus radical 3c plus 1. X approaches c. All right. So numerator, we can pull out a 3. So it's the limit as x approaches c of 3 times x minus c over x minus c times
radical 3x plus 1 plus radical 3c plus 1. Holy schmoly, look what happens. These x minus c's cancel. Now, if x is approaching c, wherever we see a c, we can replace it with an x. So let's put an x right there. So we have 3 over radical 3x plus 1 plus radical 3x plus 1. All right. $3 plus $3. No. $1 plus $1 is $2. 1 car plus 2 cars. No, 1 car plus 1 car is 2 cars. 1W plus 1W is 2W. 1 radical 3x plus 1 plus 1 radical 3x plus 1 is equal to 2 radical 3x plus 1. So this becomes 3 over 2 radical 3x plus 1s. And there's our functional derivative. Now, what does that mean? Go back to the original function right here. If we were to graph that, we would know the slope of the tangent line at any x value by taking that x value and plugging it into 3 over 2 times the square root of 3x plus 1. So if we wanted to find out when x equaled 5, put a 5 in right there. 3 times 5 is 15 plus 1 is 16. Square root of 16 is 4. 2 times 4 is 8. It would be 3/8. All right, so we did a polynomial function. We did a radical function. Now let's do a rational function. Suppose f of x is equal to 3 over x minus 2. Then f of c be equal to 3 over c minus 2. So we have the limit as x approaches c, f of x minus f of c over x minus c. So let's do some plugging and chugging. It's the limit as x approaches c. F of x is 3 over x minus 2 minus f of c is 3 over c minus 2 all over x minus c. Okay, we have a complex fraction. Change the main division bar to a division sign. So it's the limit as x approaches c of 3 over x minus 2 minus, oh, we got some barking issues going on here. Stop. Sorry about that. Okay, and then they don't listen to me, so they're going to keep it going. So times 1 over x minus h. I changed the main division bar to division sign. All right, remember what I told you earlier about adding and subtracting fractions. Okay, the common denominator is going to be x minus 2 times c minus 2. So here we'll have 3 times c minus 2. Then minus 3 times x minus 2. Bella, stop. Sorry about that. Times 1 over x minus c. Boy. So we have limit as x approaches c of, okay, let's look at this numerator in all of its beauty. We have 3c minus 6 minus 3x plus 6 over x minus 2 times c minus 2 times 1 over x minus c. All right, the 6's cancel out. So we'll have the limit as x approaches c of 3c minus 3x over x minus 2 times c minus 2 all times 1 over x minus c. Now, look at we can factor out a 3 from the numerator. So it's the limit as x approaches c of 3 times c minus x over x minus 2 times c minus 2 times 1 over x minus c. Oh my gosh, look at this. We have c minus x and x minus c. Hopefully you remember when we have that, we can cancel them out and put in a -1. Because c minus x over x minus c equals -1. I proved that to you in class a couple of times. So it's the limit as x approaches c of -3 over x minus 2 times c minus 2. So now we take the limit as x approaches c, we take the c out, put an x in, and we get -3 over x minus 2 times x minus 2, which is -3 over x minus 2 squared. And there's our functional derivative. So that was a long, long problem. So if we have this function right here, and we draw the graph, we could find out the slope of the tangent line at any point for x, as long as it's not x equals 2, because that would make 0 in the denominator. But anyway, any other point, and we take that x value and we just plug it into this formula. So if we wanted to know when x equals 3, 3 minus 2 is 1, 1 squared is 1, -3 over 1 is -3. So when x equals 1, the slope of the tangent line is -3. Stop my share. I'm going to start my, oh, here, ooh. Hey, I'm back, yo. All right, so, hopefully, you know, when you watch these videos, it would behoove you to pause them, take notes, watch them over and over again, but they'll be very, very useful. Okay, this is Professor Ken signing off.